We come to our third and last unit of integration by parts, which will include 5 examples numbered from 11 up to 15. The first of these, number 11, is the integral of sine inverse x all cubed dx. For this we use a substitution, y equals sine inverse x, which means that x is sine y, and dx is cos y dy, and so the integral transforms to y cubed cos y dy, which, if you look at question 10 in the previous unit, will give you y cubed sine y plus 3y squared cos y minus 6y sine y minus 6 cos y. And reverting to the old variable then fairly easily gives us x bracket sine inverse x all cubed plus 3 bracket sine inverse x squared multiplied by the square root of 1 minus x squared minus 6x sine inverse x minus 6 square root 1 minus x squared plus the constant c. So that deals with number 11. Number 12 is x times tan inverse x dx. We reverse the order of integration here to give us tan inverse x times x, and then applying the rule, we'll have the first, which is tan inverse x times x squared upon 2, minus the integral of tan inverse x differentiated, which is 1 over 1 plus x squared, times x integrated, which is x squared over 2. And so on the next line, we have tan inverse x times x squared over 2 minus a half, and that the numerator are written as 1 plus x squared minus 1 over 1 plus x squared, which will come down to the next line will give us x squared over 2 tan inverse x minus a half dx plus a half 1 over 1 plus x squared, because a minus times a minus is a plus. And so that gives us then x squared over 2 tan inverse x minus x over 2 plus a half tan inverse x, which then simplifies to 1 half bracket 1 plus x squared tan inverse x minus x close bracket plus c. Question 13 is e to the sine x bracket 1 plus x cos x dx. So we'll split that up as the integral of e to the sine x dx plus the integral of x, and for the second function we'll have cos x times e to the sine x all as one function. Okay, and continuing, we'll just write down the first term, which is the integral of e to the sine x, and now we'll integrate the second term using parts. So that will be the first, which is x times the integral of the term in the square brackets, which is e to the sine x, and then minus the integral of the x differentiated, which is 1, times the bit in the square brackets integrated, which is e to the sine x. Now, the last term and the first term are equal but opposite in sign, and so cancel out, and so this just reduces to xe to the sine x plus c. Question 14 is I equals e to the x sine x plus cos x dx. Okay, and using parts, integration by parts, it will be the first e to the x times the integral of the term in the square brackets, which will be minus cos x plus sine x. And then on the next line, minus the integral of the first differentiated, which is e to the x, times second integrated, which is minus cos x plus sine x dx. So that then will equal e to the x sine x minus cos x plus integral of e to the x cos x minus sine x dx. And then continuing, here I have e to the x sine x minus cos x, and then dealing with the integral, we'll have the first, which is e to the x, times the integral of the second, which is sine x plus cos x, minus the integral of the first differentiated, which is e to the x, times the second part integrated, which is sine x plus cos x dx. And you notice that this last bit is just equal to the integral we're trying to find. And so twice our integral will equal 2 e to the x sine x on simplification, and so I is e to the x sine x plus c. And then lastly, we'll have question number 15, which is sec squared x times 1 plus log tan x dx. And here we'll reverse the order of integration and carry out the integral, carry out the process by parts. So it'll be the first, which is 1 plus log tan x, times the integral of sec squared x, which is tan x, and then minus the integral of the first term, which will be sec squared x over tan x, times the integral of sec squared x, which is tan x, and then tan x's cancel out. So we'll then have 1 plus log n tan x times tan x minus integral of sec squared x dx, which is minus tan x. And that then just boils down to tan x times log n tan x plus c. So that completes it. So I hope that was useful for listening.